Dear students, today we'll see what do we mean by intersymbol interference, ISI. Before going to ISI, we should see a baseband transmission diagram. A baseband transmission means only the message is transmitted from transmitter to receiver without a carrier, only with the power and clock pulses. Now here we are going to send binary data from this source and we are going to receive binary data at the destination. This is what we are going to show. Now in this case, the source will generate the binary data. The line encoder will give an electrical waveform according to the pulses over here, or clock pulses, so that binary 1 will be taken as plus 1 volt, binary 0 will be taken as minus 1 volt. So it will give a line encoding for that. So a binary data is converted into electrical waveform. After that, that electrical waveform of binary data is given to a transmit filter, which will generate the PAM waves, sequence of PAM waves, sequence of pulses, which will go through the channel to the receiver. The receiver filter will accept all the sequence of pulses, and at a particular timing interval, at a particular interval rate TB, it will give to a decision device, where the decision device will check it with a threshold voltage, and after detecting the amplitude of the incoming pulse, it will tell whether the output was binary 0 or binary 1. This is the normal process of a baseband transmission. Now in this process, we have used something called as transmit filter, which will have its own transfer function. We have used a channel which will have its own transfer function, and in the receiving section we have used a receiver filter which will have its own transfer function. Transfer function is nothing but relation of output to input with respect to frequency. So this will have its own transfer function, this will have its own transfer function, and this will have its own transfer function. So in all three stages, that is transmitter, channel and receiver, we are having some other thing where transfer function comes into picture. Okay. Now when the binary code pulse is transmitted, whenever a binary number 1 or 0 is converted into pulse and it is transmitted and it is received, the synchronization timing of transmitting and timing of receiving as per the signaling rate should match. But because of this transfer functions of this, that matching doesn't properly make a suitable thing. It will not match properly. So the signals, the pulses can overlap. Say for example, if it is logic 1, what I want to I am going to expect at the end. So logic 1 should look like this in terms of the signaling rate TB. Logic 1 should look like this. But what will happen is the earlier pulse signal and the second pulse signal will get overlapped like this. And in that case, when the overlapping takes place, you cannot decode the bit at the end whether it was logic 1 or logic 0. That means there is some effect from the other bits on this particular bit to decode it properly. Decoding means from that pulse I want to see whether it was logic 1 or logic 0. So that effect, which is called as residual effect of all other bits on a particular bit which you want to decode, and you are not able to decode it properly. The residual effect of all other bits on a particular bit which you want to decode, that residual effect because of which you are not able to detect it whether it was correct binary 0 or binary 1, that effect is called as intersymbol interference. It's called as intersymbol interference. Now students, with respect to the same diagram what we have seen, I have drawn some transmitted sequence and the received sequence. So this was the transmitted sequence, say it was 1101, and this is the received sequence what has been received. So if you see, for 1 there is a pulse. For 1, there is a pulse. For 0, there is no pulse. Again, for 1, there is a pulse. But in this received sequence, you can see that whenever the sequence is received, the pulses are not properly based on their sampling time. This is your sampling time. This is your sampling time at each interval. At each interval of TB, you are having a particular sampling time where you are going to check the amplitude of the pulse. Now say in this case, this will be treated as logic 1 after you detect in the decision device. This also will be treated as logic 1. But here if you see for logic 0, this and this pulse is overlapping and there is a small amplitude. Now that amplitude will be a disturbance so there is a disturbance from adjacent pulses over here. That disturbance will make you wrong whether to detect it as logic 1 or logic 0. And that type of disturbance or interference from the adjacent pulses, whatever you get, is called as intersymbol interference. That will make your decision of choosing the pulse or detecting the binary data at the end, whether it is 0 or 1, that will go wrong because of intersymbol interference. So it is an interference by other bits on a bit which you want to decode. So it is a residual effect which is provided by other bits on a bit which you want to decode. That is called as intersymbol interference. This, along with noise, is a basic problem in baseband transmission receiving section. So that has to be eliminated if you want to get your data free of error. So ISI and noise both has to be eliminated.